Hello, my name is Jason. Today, our group will be presenting a case study project from Communication Principle of Section 3 and Section 4. Our group consists of Muhammad Aiman bin Abdul Khalid, which will be presenting about amplitude modulation, Pavitran L. Thianagarajan, which he will be presenting angular modulation, and me, Jason Lim Johnson, who will be presenting radio digital modulation.
Yeah, Assalamualaikum and hi. My name is Muhammad Aiman bin Abdul Khalid and I'm from Group 2. In this section, I will explain about amplitude modulation. So first of all, what is modulation? The message itself is a signal. As example, audio signal. A signal transformation to a format suitable for transmission through a chosen medium. So let's see some variants of amplitude modulation signal. The first is double sideband full carrier. Second is double sideband suppressed carrier. The third is single sideband SSB, and the fourth is single sideband suppressed carrier SSBSC, and the fifth is vestigial sideband. So in the component of amplitude modulation, the first is carrier frequency, the second is modulating frequency, and the third is modulating signal. So let's see what is carrier frequency in amplitude modulation. So in the amplitude modulation AM, the carrier frequency plays a crucial role. So the carrier frequency in amplitude modulation involved in encoding information onto a carrier waveform by varying its amplitude according to the instantaneous value of the baseband signal. So let's see in the simple analogy. I will tell it. The first analogy is, imagine a radio station broadcasting music. The carrier frequency is just like the radio signal itself. It's a steady wave that carries the music information. So now let's see for amplitude modulation. Now to put the music on that radio signal, we use amplitude modulation. We adjust the strength amplitude of the radio wave to match the music. When the music is loud, the radio wave gets stronger. When it's quiet, the wave weaker. So how it works actually? So amplitude modulation combine the steady radio wave carrier with the music baseband signal. The carrier strength change according to the music's volume. When you listen to an amplitude radio station, your radio detects this change and play the music for you. So let's see in recent advancement in amplitude modulation. So the first is software defined radio SDR improvement. What is this? SDR allows radios to be more flexible and efficient. The benefit is better and clearer communication, crucial for emergency service, aviation and marine communication. The second is adaptive modulation technique. What is this? Adjusting modulation setting in real time based on the signal condition. Benefit is more reliable communication even in difficult environment. So let's see addressing misconception and issue. The health concern. The misconception is amplitude modulation radio wave are harmful to health. So the truth is amplitude modulation radio wave are not ionizing and safe at regulated level. So the solution is educating the public about the safety of amplitude modulation wave. So the safety and legal issue. The issue is interference and jamming can be dangerous for critical communication. The solution is we just a better regulation and enforcement to prevent an unauthorized use, along with the advanced technology to maintain clear signal. The cultural and the accessibility issue. The issue is just moving an amplitude modulation to digital can exclude some people, especially in remote or poor areas. The solution is just support program to help this population transition, such as subsidies for new receiver or using both amplitude modulation and digital broadcast. The benefit to society. The first is emergency communication. More reliable amplitude modulation technology helps emergency service communicate so effectively during disaster. So an analog communication system consists of modulator, demodulator, and the final is transmission modem. So I will pass it to my next member. Thank you.
Hello everyone, my name is Pavitran and I would like to present about angle modulation. Okay, what is angle modulation? In angle modulation, frequency or phase of carrier signal changes with respect to modulating signal while keeping the amplitude constant. This modulation is introduced in 1931 by Edwin Armstrong. angle modulation that is classified into two parts, which is frequency modulation and phase modulation. In frequency modulation, frequency of carrier signal changes with respect to modulating signal, whereas in phase modulation, phase of carrier signal changes with respect to modulating signal. Okay, now we can see the relationship between the frequency modulation and the phase modulation. We can generate FM signal by using PM modulator and vice versa. From the table, it can be shown that the generation of the frequency modulation and phase modulation signals are mutually related. The demodulation process is used to get back the information signal. For FM demodulator, in order to get back information signal from FM signal, PM demodulator is used and the signal is passed through the differentiator. In contrast, for PM demodulator, FM demodulator is used and the signal passed through the integrator. Okay, now we can see the recent advancement in angle modulation, which is ultra narrow band modulation. Ultra band modulation technique are particularly used for applications like low power wireless networks and long range communication. Unlike the traditional angle modulation, where the carrier frequency of phase is varied continuously. From the ultra narrow band modulation, we can get a very narrow transmission bandwidth, so that this enables more devices to coexist in a limited spectrum. At the same time, it also causes low power consumption, which is ideal for battery powered device in the Internet of Things applications. Okay, now we move to addressing misconception and issues. For health, some people misunderstood that radio waves from angle modulated signal can be caused health problems. While high power radio waves can hit tissue, the power levels used in most angle modulated transmissions like FM radio or Wi-Fi are well below safety guidelines set by regulatory bodies. Moreover, some have misunderstood that angle modulation is inherently less reliable than other methods for safety critical applications like aviation communications. But the truth is, with proper design and implementation, angle modulated signals can be very robust against noise and interference, making them suitable for safety applications. Moreover, some have misunderstood that anyone can use it freely. But the angle modulation process have regulations government that use specific frequency and power levels to avoid interference with other users. Last but not least, there are some benefits of angle modulation to the society. Firstly, FM radio offer significantly better audio quality. This is because FM is less susceptible to noise and interference, resulting in clearer and more enjoyable listening experiences. After that, by using different carrier frequency, multiple signals can be transmitted simultaneously without interfering with each other. This enables a wider variety of services, like multiple radio stations or numerous Wi-Fi networks. Then, angle modulation forms the basis for many modern communication technologies, such as Wi-Fi, Bluetooth, and mobile phone networks. Okay, that's all from me. Thank you.
Digital modulation is the process of converting digital data into an analog signal that can be transmitted over a communication medium such as radio waves. There are various digital modulation techniques that exist. These are the types of digital modulation. We have amplitude shift keying, ASK, frequency shift keying, FSK, phase shift keying, PSK, and quadrant amplitude modulation, QAM. Amplitude shift keying, also known as ASK, modulation involves varying the amplitude of the carrier signal to represent binary numbers, like for example 1 and 0. Example, Binary number 1 is equal to high amplitude. Binary 0 is equal to low amplitude. The frequency and the phase are constant. Frequency shift keying, also known as FSK, frequency of the carrier signal is varied according to the digital data. Example, binary 1 is equal to high amplitude, binary 0 is equal to low amplitude. The amplitude and phase are constant. Phase shift keying, PSK. Phase of the carrier signal varies with respect to the amplitude of signal. Phase would be equal to 0 degrees or 180 degrees. The binary input would change between 0, 1 and 1, 0. Phase change at 180 degrees. The amplitude and frequency remain constant. So there are advantages and disadvantages between the amplitude, frequency, and phase shift keying. With the amplitude shift keying having more noise but more bandwidth efficiency. With the frequency shift keying, we'll have less noise and larger bandwidth, and the phase shift keying will have less noise than the amplitude shift keying and frequency shift keying, but it will have a similar bandwidth to the amplitude shift keying. Next up is what we call multi-level shift keying, where more than one bit can be represented by a symbol. So what is a symbol? The final signal representation before transmitted through physical medium, example amplitude, frequency, or shift or phase. The symbol rate is the baud rate, which is the bit rate divided by n equals the bit rate divided by the log 2m. In general, m is equal to 2 power of n symbols are required per n bit. For example, 2 power of 2 or 4 distinguishes symbols are needed to represent 4 combinations, being 00, 01, 10, 11 that uses 2 bits. For 3 bits, it's similar with 00, 001, 010, 011, 100, 101, 110, 111, which it's a 2 power of 3 or 8 symbols. For 4 bits, it's similar with 4 numbers with 000 or 1111, which are 16 symbols. This technique is applicable to amplitude shift keying, frequency shift keying, and also phase shift keying. But multi-level phase shift keying has proven to be a lot more useful. 2-bit symbols can also be a 4 combination of levels to 4 symbols, then to 4 phase shift keying or quadrant phase shift keying. Quadrant phase shift keying or QPSK is the multi-level of phase shift keying, being 4 symbols, n equals to 2 bits. For 11 it's 45 degrees, 01 135 degrees, 00 being 225 degrees, and 10 being 315 degrees. Next we have the last one, which is quadrant amplitude modulation, QAM. 2 carriers with phase difference of 90 degrees are modulated and each having the same frequency, variation, amplitude, and phase. Why should we use radio digital modulation? What are the advantages? Well, it has higher data rate, better security and privacy, and multiple access. Thank you for watching.